I really prefer the reading this as a sentence method. It makes your life a little easier. We'll talk about how I can plug in ends on the fourth one, but for the third one, I'm going to do reading the sentence. So let's read this as a sentence, and that is a sub n is the term I want. A sub n plus 1 is the term I want. What is a sub n minus 1 in reference to a sub n plus 1? Well, it's 2 terms before. Plus 1 to negative 1 is 2 terms before. So that is 2 terms before. So if I'm just reading this as a sentence, my third term is going to be 2 terms before. My term before is 7. My term before that is 5. So 2 terms before is 5. So I'd plug a 5. And then I pull this 5 from this plus 5. So it's 5 plus 5. Noting the first 5 comes here. The second 5 comes from the formula. So that means my third term is going to equal 10. My fourth term should be 2 terms before, which would be 7, plus 5, so it would be 7 plus 5. Let's pretend I forgot how to do that method. I don't quite know how to read it. You can still use your n values, but this one's a tricky one to use your n values on, because if you look at, this is a sub n plus 1. So when I'm looking at that 4, I'm actually looking at n plus 1. So to make that 4, it would have to be 3 plus 1, meaning that n equals 3 in this case. So even though we're at a sub 4, n would equal 3. So if I plug it in the other side, I'd have a sub 3 minus 1 plus 5. Noting that a sub 3 minus 1 is a sub 2. A sub 2 was 2 terms before. That's 7 plus 5, which equals 12. So the correct answer was D. D12. Isn't that a band? For D12? I think it was a band. Eminem? Any of that offshoot band? No one? Maybe it's wrong. Maybe it's not D12. Anyway, any questions on that one? Maybe I'm just old too. All right. Our next one is we're supposed to write the series in summation notation. Summation notation means that I need to come up with a explicit formula for it. So that means it might be arithmetic, it might be geometric, but I'm going to quickly notice that it's neither of those. So that means I need to think about, is that 1 actually being 1 over 1? So I can picture my denominator being 1, 2, 3, 4. That is arithmetic because it's actually plus 1. Plus 1, plus 1, plus 1. So my arithmetic sequence would be a sub n would equal, what, my first term plus n minus 1 times my common difference, which is 1. Well, that should just equal n. Most of the time, you shouldn't have to write this whole thing out. This is just 1, 2, 3, 4. That's just n. Okay, that means my summation formula is going to use n in it. I do know that it's going to be 1 over n, so I can keep those n's. How do I alternate between positive and negatives? How do I alternate between positive and negatives here? Yeah.
Negative 1
to the what? I'm sorry. Power of n?
yeah.
Okay, let's check it. So negative 1 to the n means if I plug 1 in, I would get out a negative 1, which means my first value should be negative. It is negative. So that would do our alternating between negative and positive. If Theo said negative 1 to the n minus 1, that would give my first term as positive. All right, then we're always going to start at n equals 1. We're going to plug in 1 first. That will give us our 1 over 1. And we have a dot, dot, dot in there, so this can be to infinity. And okay, there's our bell work. Let's look back at our homework that was due today, because we should have questions. And what questions do we got? Yeah.
21.
21. Okay. I think an easy way to do 21 is to break it apart into 2 kind of situations. So let me take a picture. I'll erase the answer, pretend like I don't know it. There's that. Let's pretend like we don't know the answer. Let's see if we can get the same answer. I think this is easier to treat as two parts. I have a number part, and I have a variable part. So I'm going to treat this two different ways. So I'm going to start with just that 2 over. So I'm just going to focus on this section right off the bat. That's all I'm going to talk about in the beginning. So when I plug a 0 in, so we're going to plug in 0, 1, 2, and that's it. So when I plug a 0 in, we're going to have 2 over 0 factorial times 2 minus 0 factorial. Now, we just got to remember that 0 factorial is 1. Otherwise, we can't do this problem. Well, this would just be 1 times 2 factorial. 2 factorial is 2 times 1. So this is really just 2 over 2, which would just equal 1. Let's keep going. Now we'd have 2 over 1 factorial times 2 minus 1 factorial. Well, 1 factorial is just 1. 2 minus 1 is 1. That's also 1. So we have 2 over 1, which would just equal 2. Our final coefficient would be 2 over, well, now we have 2 factorial times 2 minus 2 factorial. Well, 2 minus 2 is 0. 0 factorial is 1. So this is really just 2 factorial, which is 2. This should turn into 2 divided by 2, which should equal 1. Now I'm going to talk about the term after it. So the term after it, that just includes the a and the b. So when I plug in a 0, we're going to have a squared minus 0 to the b to the 0. Well, b to the 0 is just 1, so that's just a squared. When I plug 1 in, I'm going to have a to the 2 minus 1, b to the 1. 2 minus 1 is just 1, so we're going to have a times b. And then our final one, we're just going to do it to the second, 2 minus 2, b squared. That's going to equal a to the 0th, which is just 1, and then we have b squared. So when I combine these together, we're going to have 1a squared plus 2ab plus b squared. You see that?
Yeah.
Okay, good. I really like the break it apart into two. It's hard to write it all out and keep it consistent. So I'm just going to break this apart. It's much easier to do on our head and on our paper if I separate the two elements and do them individually. All right, other questions? Other questions? It did, really? Yeah, there we go. Thank you. Yeah. Yeah. Number 10, it looks like we got 1 minus 1/2 plus 1 over 4 minus 1 over 8 plus 1 over 16. Now remember, when I'm looking at the pattern for this, I'm thinking this as being 1, negative 1/2, 1/4, negative 1 over 8, and 1 over 16. Now, if this is arithmetic, I have to worry about that negative 1 to a certain power. It's going to turn out this is not arithmetic. It should be geometric. Because if we look at to get to 1 to 1/2 using multiplication, to get from 1 to 1/2, I'd multiply by 1/2. Well, to get to a negative 1/2, I must multiply by a negative 1/2. If I try that again on here, if I multiply negative 1/2 times a negative 1/2, that will give me a positive 1 over 2 times 2, which would be our 4. And if I do 1/4 times a negative 1/2, I'm also going to get to that. So this is a geometric sequence. Did I ask for that form? Yeah. So it's a geometric sequence. For a geometric sequence, we're going to take that first number, which is 1, and we're going to multiply it by our common ratio, negative 1/2 to the n minus 1. Now we can just take that and throw it down here. So we're just going to take the negative 1. I don't need the 1 out front. We have n equals 1. And we got how many terms? We got 1, 2, 3, 4, 5 terms. So we're going to go n equals 1, 2, 5. Is that good? Other questions? Jacob.
You over 12?
12? Yeah. So 12, what we're going to notice is that we have A plus AR, and that's the equal sign, plus AR squared, dot, 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 and then we get to AR to the 10. So the first thing I'm going to recognize is we have A in all of them. So when I set up my equation, I'm going to have A. I'm also going to follow a pattern. This goes 10, 9, 8, 7, 6, 5, 4, 3, 2, R to the first, which means there must be an R to the 0th here. So we're multiplying A by R over and over and over again. So we're going to go A times R. And before I go any further, I'm going to start with n equals 1. In order for my first thing to be R to the 0th, I would need to have n minus 1. And that would go all the way till actually 11. Because when I plug 11 in, that will give me my to the 10th. An alternate version to this one is you could do the summation of AR to the n, where we let n equal 0 to 10, and both of those are the exact same thing. That's just a change of index. My index went from 1 to 0, so that means I add it to my variable. Other questions? Okay, then let's talk about Gauss. Let's talk about Gauss and why my slide is messed up. All right, the history goes that Gauss was a pretty fun student to have, let's put it that way. He was a very smart guy, and he let his teachers know how smart he was every single day. So one particular day, his teacher got annoyed of his antics in class and said, go sit in the corner until you add 1 to 100. Now, he was just in elementary school, so the teacher thought it was going to take him a long time to do it. No calculator, had to do it all by hand. Well, he sat there for like 10 seconds and came back and said, oh, it's 5,050. Well, she didn't know the actual answer, so she said he was lying and sent him back there to actually show his math. And he came back 10 seconds later and goes, no, it's 5,050. All the work, it works out. And so she had to sit there and add it all out, and sure enough, it came out to 5,050. Well, Gauss is credited with coming up with this idea that if I need to add the numbers 1 through 100, it's a waste of time going 1 plus 2 is 3, 3 plus 3 is 6, because what he noticed is there's a pattern in there. There's a pattern when you match up all of the pairs. So if you take 1 and you add it to 100, you get 101. If you take 2 and add it to 99, you get 101. If you add 3 plus 98, you get 101. If you add 4 plus 97, you get 101. And you keep working your way in, and you just have a series of 101s. The hard thing you need to do is you need to figure out how many of these pairs do you have. Well, if you have 100 numbers and you're pairing them all up, all we have to do is our n is just going to equal 100 divided by 2. We would have 50 pairs. Well, if I have 50 pairs that are each 101, all you have to do, the only math you have to do is do 50 times 101. And that comes out to 5,050. Well, it turns out what Gauss did with 1 to 100 works for any arithmetic series. So anytime you have an arithmetic sequence that's being added, we can use this idea that if I know what each pair is, And the easiest way to come up with what each pair is just take your first term and add it to your last term. Everything in between will also add. If you can come up with those two things, you can come up with the sum. So number of pairs and what your pair equals. So through that little formula with adding 1 through 100, we have this formula where we're going to start with n divided by 2. Now what I want us to think about is less memorizing this formula and more understanding why it's doing it. So n divided by 2 is your number of pairs. Well, I need to know what the pair's worth. I can't just multiply the pair by nothing. So the number of pairs is going to be what's the pair combined. And the easiest way to come up with that is take your first plus your last. So that a sub n is going to be your last term. Add those together and you know how much each pair is equal to. So when I'm adding 1 to 100, my first number is 1. My second number is 100. 1 plus 100. How many pairs? 100 divided by 2 is 50. 50 times that 101. And you can now add all of those up versus going to your calculator and going 1 plus 2 plus 3 plus 4 plus 5. All right. There's another formula for it. We're not going to use it. In fact, I always have to look it up to make sure I'm putting it down right. So why take an easy formula and make it hard? I don't know. Someone's got to do it. But another way you can come up with your sum is you can do n divided by 2 equals 2 times a sub 1 plus your common difference times n minus 1. Yeah, this formula is nice when you can't find your last term, but if you knew all of this information, you can find your last term. So why am I going to memorize a more complicated formula? If you want to, you can sit there and memorize it. I'm going to say don't use it. This is something more intuitive. How many pairs do you have? How much is each pair worth? This is less intuitive and much more likely to mess it up. Yeah, go ahead.
Like you're given like a sequence, could you just like get the use an explicit formula and get like your last term?
Yep. That's what we're going to do. So rather than memorizing this and trying to, because this basically is our explicit formula, right? I'm going to multiply this by 2. And it's just remembering these little details that messes it up. So we're going to use, so like you said, if you know your explicit formula, why not just use that to get your last term? And that's what we'll do. Okay. Questions on those two formulas? So we're going to use that first one. Maybe write don't use, because we have a test next Thursday, and I was notorious for that in math classes. I wouldn't put notes to myself, so I'm like, I'll remember that. And then you start looking at your notes the night before, and you're like, what did I mean by that? So let's take good notes and say, don't use this one, let's use this one. Okay, so example, find the sum of these two things. Well, to find our sum, we need to know how many we have. We need to know what the first pair is, or what the first number is, and what's the last number. So our n in this case would be 1, 2, 3, 4, 5, 6, 7. So our n is 7. Our first term is 40. In fact, if you wanted to, I could erase that and go, I'm actually looking for a sub 7 because I do know my n. My seventh term is 22. That is all the information you need to come up with the sum. Our sum is how many pairs do I have? Well, note we have an odd number. That's okay. The odd number is going to work. It's still going to be fine. We're just multiplying by an odd decimal. 7 divided by 2 is still going to work. So you don't have to have an even pair, and it will still work. And then we'll do our first number, which is 40, plus our last number, which is 22. So we're going to type in our calculator 7 divided by 2 times 40 plus 22. Make sure you use your parentheses. If you do not use parentheses, what your calculator is going to do is going to go 7 divided by 2 multiplied by 40, and then it's going to add 22. Or you purposely can do 40 plus 22 and then multiply by 7 divided by 2. Emphasize, use your parentheses. What is the sum for this one? Yeah, Libby. What was it? 231. Got a second on that?
217.
217. I think it's 217. You probably just added it again. You probably just added one more time. So we got 217. All right, we got 1 through 35. Now, n. We got to be careful with n sometimes, because if this is 2 through 35, we would have a different answer. What I'm thinking about in integers is, if I just give you a 1, you have one term. If I give you 2, you have 1, 2, you have 2 terms. 3 is 1, 2, 3 terms. 4 is 1, 2, 3, 4 terms. So 35 must be 35 terms. So our n would be 35. Be careful on these, because I could say, what are the integers from 2 to 35? In that case, we have to subtract 1, and we'd have 34 terms. So you actually have to know how many terms there are. In this case, there's 35 of them, because we are counting 1 through 35. Our first term is going to be 1. Our last term, well, that guy is going to be a 35. Okay, so our sum is going to equal 35 times 1 plus 35. Oof. What did I mess up? It's wrong. It's wrong. Jacob, what's wrong about it?
You did not add 1.
I added the 1. Thomas?
You didn't divide by 2.
I didn't divide by 2. Love your enthusiasm, though, Jacob. I just love when you raise your hand. You're like, I'll figure it out. All right, so we have to do divided by 2. Otherwise, we're going to come up with the wrong answer. All right, 35 divided by 2 times 1 plus 36. What is our total sum going to be? Who's got that? Yeah. 35.5? I think that's going to be a little bit off.
Okay.
630.
Because let's just think about that. Like 35 plus 1 is 36. Even none of the numbers in between.
I did plus instead of time.
That will be a difference. Will, what'd you come up with?
630.
630. Did anyone else come up with 630? Okay, we're good there. I think on a test, if you answer that, I'd be like, are you sure? Are you sure when I add 1 plus all of them? All right, so we got 630. Awesome. All right, find the sum of these next two. This is going to be our hardest one. In the homework, these are going to be the hardest ones. These are pretty easy as long as you know what's going on. And I'm going to put an addendum on there in just a second. Actually, right now, let's talk about that 1 and 15. We go from 1 to 15. Your job is to come up with how many terms you have. You have to come up with your n. Now, I think the easiest way, let's all pay attention to this because this is important coming up. It's easy on this one. Our n is 15. Awesome. Good job. 1 through 15 is 15. This is for the future when you don't have 1 through 15. So pay attention to this. I think the easiest way to do this is take that 15 minus 1, which will give you 14. Sounds wrong, but that's how many steps you have. 15 minus 1 is how many steps you have. How many steps you have links you to how many you have. Think about if I give you 1, 3, and 6. I have 2 steps. 2 steps. So 2 steps means you have 3 terms. 3 steps, 9, means you have 4 terms. So if you ever do 15 minus 1, you have to add 1 back in for your first term. So the easiest way when it's like this, I would do 15 minus 1 plus 1. If this was a 3, I would do 15 minus 3 plus 1. If this was a 5, I would do 15 minus 5 plus 1. You have to do that plus 1 to account for your first term. When you subtract them, that is just how many steps you have. You may want to write that down. That's going to be important. So in this case, we're going to have, maybe I'll even do that. So we have 15 minus 1 plus 1, which would equal 15. I wouldn't do it on that one because it's just 1 through 15. It's 15. So our n equals 15. Now I need my first term. Our first term is just plugging 1 into this. Note your first term is not always just plugging. If this was a 2, my first term would be plugging 2 into it. In this case, I do start at 1, so I'm going to plug a 1 into that. So we'll have 3 times 1. I like parentheses better than multiplication. Minus 5. 3 times 1 minus 5 is a negative 2. Then we're going to do our last term. Our last term is when I plug in 15. We'll have 3 times 15 minus 5. Well, that's going to equal 40. It'll be 45 minus 5, which would be 40. All right. I got a little wall there. So our sum is going to equal our n value. Remember, that's how many pairs I have. I have 15 divided by 2 pairs. And we're going to multiply that by our first term plus our last term. Even though there's a negative in there, it's still going to work. It's still going to work. So we have 15 divided by 2 times a negative 1 plus 40. What is that going to equal? Go. 285. Can someone second that?
Yes.
Cool. We got 285 is our sum. All right, like I said, the last one is probably the hardest one. It is where you don't know how many terms you have. So let's write down what we know. So we don't know how many terms we have. Let's start with that. N is a mystery. I do know what my first term is. That's 36. I don't know what we're going to plug in this, but I'm going to put my last term is 91. So I'm going to say a sub n equals 91. Some value that I plug in here is going to equal that 91. Well, in order to work on this, we're going to need a formula. We're going to need a formula in order to actually solve this mystery letter. Well, the good thing is we're dealing with just arithmetic sequences today. This is plus 5, plus 5, plus 5. Plus 5, plus 5, plus 5. Can someone help me with the equation for an arithmetic sequence that has plus 5s? Just start me off. Don't do the simplified version. Jacob.
AN equals 36. Let's see. Oh yeah, sorry. Plus
Yep.
n minus 1. 5.
Times 5.
Times
Yep.
5.
That would be it. So we distribute that 5, and this would actually equal 5n. 5 times negative 1 is negative 5, plus 36 is a plus 31. There's my equation. I have a sub n equals 5n plus 31. Here's how we're going to solve for this n. Note our last term. The n for this last term should tell me how many terms I have. So what we're going to do is we're actually going to take that 91 and we're going to plug it in for that a sub n. We're going to say this is the guy I don't know what term it is. I know my first term. A sub 1 equals 36. A sub n equals 91. That's going to help me find my n. Because this n right here would be the same n here, and it'd be the same n here. So we're looking at our n's, and those would all be the same. So that n would all be the same number. So when I plug in that 91 times 5n plus 31, we're going to subtract 31. We're going to come up with n equals 12. That seems right. Now I got everything I need. I got my n value. I got my a sub 1. I got my last term. So now we can go ahead and do our sum. Our sum would equal, how many terms I got? I got 12 divided by 2, so really I have 6, times our first term plus our last term. I definitely need help on this one. So we're going to do 36 plus 91 times 6. What are we going to get out for that one? Yeah, what'd you get?
762.
762. Can I get a second on that?
Yeah.
Okay, we're good. 762 is our sum. All right, let's get to everyone's favorite, and that is word problems. Everyone loves them. Everybody loves them. We'll break it down like we do this chapter. It must be some kind of arithmetic sequence because we're looking for sums. So we're going to talk about this in terms of an arithmetic sequence, and let's see how it could be an arithmetic sequence. So let's go back. So it says, find the total salary of an employee who is paid $20,000 for the first year and receives $1,200 raise each year for the next 39 years. Also find the mean of the 40 annual salaries. Okay, so basically what we have is a guy that makes $20,000 his first year, or a woman, just his employee. All right, he or she makes $20,000 their first year, and then they get $12,000 or $1,200 raise every year after that. That sounds arithmetic, where I start with a number and I keep adding the same number over and over. I keep adding 12,000. So this is arithmetic. So we can think of this as being an arithmetic sequence. Get out of there. Get out of there. All right. It's an arithmetic sequence whose first term equals 20,000. I'm also going to note that my common difference is 1,200. Let's talk about what we need to solve this problem. So, for starters, it wants the sum of all the salaries. Now remember, our sum formula is n divided by 2 times our first term times our last term. Well, we have our first term. We are going to have our n value in just a second. We actually have it. It's 40. How many 40 salaries? But I'm going to talk about the more pressing one, and that is, what is the last salary they received? How much did they make that last year? Well, in order to come up with that last year's salary, you can either, add 1,200 over and over and over, or we can come up with that arithmetic sequence. So our explicit form of our arithmetic sequence would be a sub n equals our first value plus our n minus 1 times our 1,200. So that's going to give me a nice little sequence where a sub n equals, that would be 1,200n. 20,000 minus 1,200 is going to be, so we're going to have plus 18,800. So that's important. That's our equation. Maybe I would continue working on this side, but I'm going to switch over to here to see what we got. So we know that the first term equals 20,000. What did I say our n was? What would our n be on this one? I said it before, I shouldn't have. But what is our n value in this one? How many total terms are we going to have? Yeah.
40.
We're going to have 40 of them. 40 salaries. Our n is going to be 40. Do not be thrown off by this 39. They get paid their first year, and they get 39 raises. This is, once again, you have 39 steps, which means you have 40 terms. Okay, so our n equals 40. So if I want to figure out my last term, that would be a sub 40. That would be our last term. We're just going to plug 40 into that equation. So we'd have 1,200 times 40 plus that 1,880. What's the last salary that person received? I assume they retired. Libby. 66,800. Any dispute? Okay, so now we have our first term, our n, and our last term. That's all we need for the sum. So our sum is going to equal our n value, which is 40, divided by 2, times our 20,000 for our first year, plus our 66,800 for that last year. And that sum comes out to some million something. What does that come out to? Someone new. Someone I haven't heard from. Take a chance. Plug numbers into a calculator. Be wrong. I'll give you an answer. It's $40. That's wrong. Sorry. All right. Someone else give it a shot. Someone new. Someone new. Looking for someone that hasn't really given an answer yet. I guess you haven't for a while. What'd you come up with?
1,736,000.
I believe that is correct. Any seconds on that? Okay. So that is his total sum. That person's a millionaire if they just saved everything for 40 years. How hard would that be? All right. But it does ask for one more thing. It asks for the mean. With this section, I'm going to bring a notation to you. X bar is going to stand for mean. If you haven't taken a stats class or anything, X bar stands for your mean. Now, as a reminder, your mean is always your sum divided by how many items you have. Sum divided by how it's distributed. So we know our sum and we know our n. So our average is going to be the sum, 1,736,000, divided by our n value, which is 40. What is that going to equal? What was that? Did I put the wrong thing down? Oh, 40. Did I say 4? I just didn't write it down. I've been having that problem today. Oh, last class it was just like everything I said the right thing, but I didn't write it down. What is that sum? What is our average? I'm going to hurt. Abraham, what's our average? 43,400.
Yeah.
Cool. Any deniers? Okay. So our average is going to be 43,400. All right, that's it. Your homework does have some word problems. I do not want to see tomorrow you have 3 blanks with question marks on them. You have to at least try them. All right? You can look online for hints, and you can ask questions still, but I shouldn't just see blank stuff like I looked at the word problem and I'm not good at word problem, so I'm just going to put a question mark. That is not acceptable tomorrow.